Hi everyone! This is now our last video for the first grading period. This is the practice exercise for lesson number 2 of our unit number 4, mainly concerned on the scientific or writing scientific notations. But for this video, we are not going to write any more scientific notations. Rather, we're going to do the other way. In the previous video, we were able to write scientific notations from the standard form of real numbers. As for this video, we are going to write the standard form of numbers from the scientific notations. So we just need to take the concept of the form of scientific notation, how it came to be, what are the processes that made it that way, and let's just reverse the operation. Why do we need to have this reverse operation? Think that mathematics is just a product of, um, is just a combination of two different operations that go different in different ways. Just like the presence of the subtraction and addition, the presence of division and multiplication, the presence of the principal roots to the perfect nth numbers. This is also the purpose for that. We also need to understand how to write the standard form of numbers from the given scientific notations. Okay, without further much talking, without further ado, let's try to look at our practice exercise. Okay, so our practice exercise will only cover, right, for a while. Yeah, this one. We only have 6 items here, which are already in scientific notations. And right now, we are going to give the standard forms for each. But first, let me remind everyone that when we actually get a value of the exponent for the multiplier 10, which is positive, in the previous operation, we move the decimal point to the right. So to write it in standard form, we're going to go move it to the left. For negative exponents for multiplier of 10, we actually move the decimal point in the standard form to the left. And right now, we're going to do the reverse operation. We're going to move it to the right. Let's try to illustrate it using number 1. You have 9 point. Let me just simply write it. I would love to write 9. Sorry for that. 9 point 876. Sorry, 876. Pardon, it's not working for this time. 876. What's happening? All right, times, that's 6, times 10 to the power of 3. Okay, for a while, something is not working. Okay, so we have here 9.876 times 10 to the power of 3. Again, when you say power of 3, we actually move the decimal point earlier 3 steps. So to return that, to remove this notation, to return it to the standard form, let's move the notation to the left. So this would be removed here. So 3 steps. You have here 1, 2, and 3. Therefore, our answer here for is the standard form for number 1 is 9,876. Do we need a decimal point here? Not necessarily, because the number of significant figures for number 1 is 4. Again, the multiplier 10 here and the exponent doesn't count as significant figures or digits because we are talking about digits. So we have 4 significant digits here. And the standard form also has 4. 1, 2, 3, 4. In short, this is the correct standard form for number 1. Number 2. Number 2 is 2.3 times 10 to the power of negative 1. Okay? So we actually move the decimal um, point to the left one step earlier to get the scientific notation. So to return, we need to move it to the right. Okay. And therefore, you have here, take note that the significant figure here, we only have two significant figures. So we need to retain that in our standard form. So you have 0.23. You have two significant figures, and this will be removed now. Okay. If we're going to place, you could actually answer that, or you could also answer here 0.23, because in the first place, the leading zero here will also not be counted as a significant figure. So this also has two significant figures. We just for reference, they are just placed there for just for placement. Okay, we're just writing it there to determine that the decimal point is placed there. Number three. So you have 1.00 times 10 to the power of 2. So we need to return it to the left to remove the positive here. Don't be confused, huh? When standard form, writing standard form to scientific notation, movement to the right is positive, movement to the left is negative. But the reverse for that, from scientific notation to the standard form, movement to the right becomes positive. For positive exponent is movement to the left, the negative exponent is movement to the right. Not be confused with that. This is positive exponent, we move it to the left. So you have here 1 times 10 to the wala na pong times 10. No more times 10. So you have 1 here. Okay. Is it really 1? You have 100 because the decimal point is here. But when you try to determine the significant figures for number 3 in the in scientific notation, these trailing zeros will be counted as significant. In short, we have 3 significant figures here. But in our answer 100, there's only one significant figure because the trailing zeros here will not be counted. So to do that, you simply need to add here a decimal here so that they will be counted as significant. That is part of our rules for significant figures. Number 4. So you have 5 point, that's point here, 47 times 10 to the power of 6. This is positive. So we move here 6 steps to the left to return it to its standard form. So you have 5, you have 1, 2, add more zeros, 3, 4, 5, 6. Again, from here, 1, 2, 3, 4, 5, 6. So that is why we have this answer. But why do we add zeros here? Because these zeros here will not be counted as significant figures later on, but they will be counted as part of the standard form. In a significant figure of number 4, the significant figure is 3. If we will use other numbers here, such as 1, 9, 6, and 7, they will all be counted as significant. So we can only write here zeros. And unlike number 3, do not write here decimal. In number 3, we need to write decimal here because to retain the number of significant figures. But in number 4, if you're going to write decimal point here, this will be counted. In short, they will have 7, where in fact we only have 3. So unlike number 3, no need for the decimal point. Number 5. Number 5, we have 8.231 times 10 to the power of negative 7. So it's a negative exponent. To return, we need to go to the left. And how many steps? 7. So if I'm going to have here 8, 2, 3, 1, 7 steps. 1, 2, 3, 4, 5, 6. Sorry for that. Again. 1, 2, 3, 4, 5, 6, 7. The decimal point shall be placed here. So what are the values of the digits we place here? Right? Again, we choose the digits that will not be counted as significant figures. Why? Because in the given you only have significant figures. 4 significant figures. So we need to retain the four significant figures. So these digits here should not be significant. So we simply place zeros. So what this would become 0 point. We could actually add another zero here because it's still not significant. Here, 0, this two, 0, this one, 0, this area, 0, this digit, 0, another digit, 0, 8, 2, 3, 1. Let's try to check how many steps. 1, 2, 3, 4, 5, 6, 7. Take note, -7. Okay. And how many significant digits are here in the final standard form? Only this non-zero digits. The trailing zeros will not be counted. So we retained the significant digits of 4. As to the last item, well, last item for first grading, 5.60 times 10 to the power of -4. The significant digits for the given is 3 because this 0 here will still be counted as significant. So take note of that. 3. And we move here 4 steps to the left to return the negative sign. So 4. 1, 2, 3, 4. Don't be confused with 6 here. That's just a item number. So this would become 0 point, this area, 0. Then this one, 0. Here, 0, 5, 6, and 0. Let's check how many steps. 1, 2, 3, 4. That's good. And why do we add here another 0? Because again, we need to retain the number of significant digits. We have 1, 2, 3, except for these trailing zeros. So that is actually how do we write numbers from scientific notation to its standard form. The key in writing standard forms to scientific notation and vice versa is to always retain the significant figures unless there are instructions not to, but basically it should be retained. Okay. um, so to review for writing scientific notations to standard form and vice versa, we still go back to the concept of significant digits and significant figures. Okay, so this is it. This is the last video for the first grading period. With this video, review the rest of the videos as part of your study and for it to be prepared in the upcoming assessment. Thank you very much for watching. Hopefully you've loved watching these videos, and we will be having more on the second grading. Thank you very much. Have a nice day. Goodbye, everyone.